Hello, and welcome to Tool Time with the Warren County Library System. My name is Sandy Roberts, and I'm the Makerspace Coordinator for the Warren County Library, which means I oversee a lot of our STEM programming, our Maker programming, and I run the Makerspace for the county. Our Makerspace is usually available at the Southwest branch in Stewartsville, New Jersey, but obviously, due to COVID-19, right now the Makerspace is closed. So I've been bringing programs to you online. One of the things I thought I'd do is educate you a little bit about what we offer through our Makerspace. So every Friday at 5 p.m., you'll find a tool time this summer to help you learn a little bit about what we offer. This week, we're talking 3D printing. 3D printing is probably one of the hottest technologies out there right now. It offers amazing possibilities, everything from being able to 3D print houses to 3D printing prosthetics for those who might have lost a limb. 3D printing is used widely by hobbyists for all kinds of creative projects, and it's used by engineers all the time to prototype items that they need to invent and create. We're even using 3D printing with our space program to send designs to the International Space Station wirelessly that they can then 3D print there on the spot. So it's pretty exciting technology, and we're really glad that we can offer 2 3D printers through our Makerspace. And those printers are available for patrons to send in their designs and have fabricated for them. You are also welcome to come into the Makerspace to see the 3D printers. Right now, they are not generally available for patrons to use directly, but working with me, we have a wide range of things that we can offer. So I'm going to give you a little bit of an overview about what 3D printing is, and then actually show you our 3D printers in action. If this doesn't give you all the information you want, there is another video available on our social media on Facebook and on YouTube called Introduction to 3D Printing. It has even more information that I'm going to go through today in a longer format, and it includes information on actually designing your own 3D printing files. Okay, so if you want even more than you can get today, go check out that video. All right, let's get started. Okay, let's learn a little bit about 3D printing. Okay, what is 3D printing? Basically, it's a process of making a three-dimensional object, a solid object, from a digital file. And that object is made by laying down layer upon layer of a melted material until the object is created. And each of these layers you can actually see. So if you look over here at this little dinosaur that's being created, you can see that there are layers. And notice that they're not all solid. We often create like a cross section, and we call that infill. So the higher the infill, the more solid the object. But by using lower infill, we can make our objects much more quickly. Now, there are a couple different types of manufacturing processes out there. Subtractive manufacturing was one of the earliest, and it's obviously still used today. And that's where you take a large block of something, or a bar or a rod, metal, stone, wood, and you chip away or carve away the pieces that you don't want, like you can see here with this stone worker or this wood carver. However, additive manufacturing lets you build objects layer by layer. So you go from nothing and you add your material to create something. You know, the oldest form would be casting and molding, but modern procedures like extrusion and lamination are all additive manufacturing processes too. Now, the cool thing about 3D printing, if we go on back here, is that this process goes directly from a digital file straight to your created object. So you're not taking the step of making a cast or a mold or anything like that. And it allows for very fine detail that can be made. It's a lot like its cousin CNC in that a robotic element or a machine element moves around and interprets that digital file to build the final object. And, you know, you can send files from your house to the library or from Earth to the International Space Station, which is a really great thing because we can trade ideas all over the world and beyond. Let's see. And okay, so how does it actually work? 3D printing feeds the material through what we call a nozzle or a hot end. So basically, this piece is metal and it heats up quite warm. and we push this metal, rather plastic-like material through it, and each layer is set on a bed that you can see here. And the whole apparatus moves up just a little bit on what we call the Z-axis. So we have the X-axis, the Y-axis, and then up is Z. If you might remember your old math days. And each layer is laid on the previous one. Now, what's important with your 3D printer is that each layer has to be just the right heat when the next one is added so that they fuse together. And they cool very, very quickly. So the whole item is actually hardening as you're building it. But it's important to note, if you have like a really short first layer and then try to build out, you're going to have trouble. You need supports for that. So that's one of the limitations of 3D printing. Let's see. So filament, this is the material that we use in 3D printers. Traditionally, it's some kind of a plastic, but now wood and metal filaments are coming out. So the choice of material is really expanding. It's kept on a roll like this, coiled. Typically, they come in 1 kilogram rolls. And there are lots of different types, like I said. We mostly use PLA, which is a non-toxic bioplastic based on corn. And we use it because it's easy to print with. It prints at a relatively low temperature, which saves energy. It comes in lots of different colors. And like I said, it's totally non-toxic, so it's safe for anyone to use. And it can even be used for food-based applications. Now, the only downside to PLA is that it does melt at what is considered a relatively low melting point of about 215 degrees Celsius, and it will deform at much lower than that. So you can't make like a coffee mug out of it because that hot liquid could deform your object. So for those kinds of things that need that extra strength or that extra heat resistance, we use something called ABS. If you're not sure what your project needs, you reach out to me and we can talk about it. Now, to design files, we use computer-aided design, which is basically software that lets you virtually create an item, and it will understand the mathematics and the geometry of that item. So there's Tinkercad, which is free, Blender, SketchUp, AutoCAD, Fusion 360. Tinkercad is free and easy to start with. Blender and SketchUp are a little tougher, but give you more options. AutoCAD 360, these are basically professional tools. Usually the files are then taken into a separate piece of software. We typically use Slicer, if you're familiar. And it literally goes layer by layer. It takes this whole design that's a solid piece and it slices it up into each layer that you're going to print. And it makes what we call G-code. And that's basically the math for the printer. You can think of it like if you have a piece of graph paper, like you see here, and you were drawing out a design, each layer is going to be a sheet of graph paper with that layer drawn on it. And the printer can interpret that and lay down each of those layers. You can also download pre-made files from places like Thingiverse if you don't want to go through the design process yourself. If you would like to learn more about all of this, I have a separate video on our YouTube channel and on Facebook that gives more detail about 3D printing in general as a technology, as well as an introduction to using Tinkercad and computer-aided design. All right, so what can you actually print? Pretty much anything that you imagine. There are a couple of things you want to keep in mind about the geometry of your creation, though. You don't want to make things that are really, really detailed and really, really tiny. If it's got a lot of detail, you want to think a little larger. If you want to print something very small, it should be a fairly simple object. And that's just because there are limitations to what our printers can do. You also don't want to make anything that's too big for our printer, okay? I'm going to go over our printers in a moment, but if you create something that's 2 feet wide, I can't print that. I don't have that large format printer. Those are very expensive machines. You want to think about the strength of your product. So if you're making a wrench, you might want to send me a note and say, hey, when you print this, can you print this at a really high infill so that I know you want a mostly solid object? Or you might ask to have it printed in ABS. A lot of times, complicated items may need what we call post-processing, which means you may need to sand it or break off a support that I added to print it well. Usually, most objects don't need much in the way of post-processing. It's really if you're doing something a little more complicated that might be necessary. For most of our printers, you can print in one color. We are adding, hopefully soon, the ability to print in more than one color, but even then it will just be by layer. So you have to kind of think about that. Often I recommend, if you're not sure, have it printed in clear or white, and you can cover it with acrylic paint, with permanent marker, with all kinds of different things. So you can add color to it post-processing. And then think about the geometry of your object. This is not something that would be easy to produce in our 3D printers. As I mentioned before, you're going to start with that base layer and go up. So if your base layer is really small and you're trying to build really wide from it, you could have trouble. Rule of thumb, 45-degree angle. If it's more than a 45-degree angle overhang, you're going to need a support. I can add those automatically in the slicer, or you can add them yourself. But if it's going to be more a sharper angle than that, you're going to have to think about supports. And again, these are all things I can help you with and things I go over in more detail in the CAD video on YouTube and Facebook. All right, so our printers, we have a Rostock 3.2, Rostock Max. This is kind of our large format printer. It doesn't print in really, really high detail. I mean, respectable detail, but the beauty of it is that we can do large items on it. So this can print up to, I think, 14 inches tall, a full 10 inches wide at circular. So it's got what we call a large build volume. This is a Delta style printer. So it's got these 3 arms that hang down and a Bowden tube that brings the filament to the hot end. This allows it, again, to do really complex geometries. So this is kind of our printer. If you're going to print like a vase like you're seeing here, I'm going to put it on the Rostock. Just be aware that large prints take a long time. So often a print that's going to take me 3 days to do, I'm going to have to push that back in the queue until I have 3 days that I can attend that printer and make sure it's going to work right, because sometimes things go wrong. Our Prusa is our finer detail printer, and this is the one that will be able to do multiple colors. This is our newer printer. It's, like I said, it does very fine detail. So it's great for those kinds of prints. This is what we call a Cartesian style printer. So it's your basic X, Y, and then Z going up. So like a Cartesian diver, the Cartesian system that you may be familiar with from school, again, from math. This one works by having the filament go directly into our hot end, into our nozzle, and it moves over a square build plate. This one can't build as large as the Rostock, but it can provide finer detail. So, if you have a preference, definitely include that when you contact me about 3D printing. Okay. So why don't we go ahead and actually take a look at one of our 3D printers and take a look on the inside of how they work. Okay, this is our Prusa. So this is our i3 NKS, which is a really great printer. It's a very popular printer. It's very portable. It's lightweight. It doesn't take up a lot of space. It's a pretty great printer. So we're really thrilled to have that. And we were able to get that through a grant last year from New Jersey STEM Pathways as part of New Jersey Makers Day. So let's talk a little bit about this printer. This is our bed. This is really nice because it actually has a removable magnetic sheet. So when a print is done, I just pull the whole sheet off, pop the print off. It's really convenient. Some printers have just a aluminum bed, and we'll often cover that with like painter's tape or with glue or hairspray to help with the adhesion of the plastic to the bed. This one, though, really you just have to kind of clean it with a bit of isopropyl alcohol and you're good to go. Sometimes we do use glue or things like that. Other printers have glass plates, which are really nice for getting a really nice fine finish. But metal plates are generally more popular these days. Our Rostock has a glass plate, and often we'll use glue for extra adhesion there. And when I say glue, I do mean like your typical glue stick. That's literally what we use, which is kind of fun. Here you can see the filament. This is a roll of filament. Let me see, is that getting, yeah. So this is a roll of filament, and you can see it kind of comes right off the roll like that. And this is obviously used, but that's what a 1 kilogram roll of filament looks like. We weigh all the items that are made, and charge everyone by the amount of filament that it uses. So it's 5 cents per gram of filament used for your design. That's what it's gonna cost through the library. At least at this point. We may have to change that. We always reserve the right to have to change our cost based on demand, right? So this comes in lots of different colors. This is a PLA filament, as I mentioned in the previous part of the video. So it's coming down, okay, into our hot end, and that's what this is. So I'm actually going to take this apart for you so you can kind of get a sense of what's going on here. This right here, okay, is actually the extruder, and then below will be the hot end. And we've got a fan here and a fan here that cool everything so that you get that adhesion to the plate and for each layer actually fusing together. That's really, really important. So I am going to go ahead and raise this up a little bit. Now, what's nice about the Prusa too is that a lot of you can change a lot of the settings right on the machine. So that's very convenient. You don't have to go to a computer. So normally, as a patron, you would not be allowed to take anything apart or directly use the printer. Usually you would send the file and I would print it, and you might be able to come in if you're having any issues. Keep in mind that a more complex design, especially if you're prototyping something new, may take a little time, may take several prints to be able to get it just the way you want it. So especially if you're doing that kind of work, working with me, emailing me, asking questions, and just telling me a little bit about what you're planning can be really helpful. Okay. I should have put a cloth down. I kind of forgot. I'll just take my metal bed off so I don't have any damage. Okay, come on. This one has been giving me. I just did a lot of calibration and maintenance on this particular machine. So I actually replaced a bunch of the parts, cleaned it all up. Needs that on a regular basis. It's not quite like your printer maybe at home, like your 2D printer. It needs a little more upkeep, a little more maintenance, a little more than just adding toner every once in a while. So I'm just removing the fans here so you can get a sense of what's going on inside. Come on, fan. Why are you not? There we go. Now I got it. Okay. So this is just a little shield to keep this fan blowing inward. Take my screw. Okay. So you can see I put my fans, as I was taking them off, onto these conveyor belt type things. These act as a pulley and they move the extruder along the Y direction, okay, back and forth. And then the bed itself moves along the X axis like that. And then if you can see them, yeah, you've got a motor here that actually moves the entire assembly up and down for the Z axis. So you've got your conveyor belt kind of thing for your Y, the bed itself for X, and then an additional motor here for your Z. Okay, so let's see. 2 more pieces and I can show you what it looks like on the inside. All of these pieces, and this is a really fun thing about 3D printing, they are printed in ABS. So if I want to upgrade, I can print my own parts for the 3D printer, which is pretty cool. Now, as we did unfortunately have one problem this winter, we had a catastrophic fail on a print. I was printing PPE for our local hospitals, which means I was making face shields. And I started a new print of a new file, and I had to go and do something else. And when I came back, it was a big melted mass of plastic all over the hot end. And that was bad. So it actually damaged a bunch of these parts. When I had to go to remove it, I had to use heat to remove it. And so I actually had to have somebody else print the parts for me. But again, we were able to do that. And that's kind of the thing. It's kind of a self-replicating technology. Okay, so now you can see, I'm just going to go ahead and take this off. This is just a bit of silicone that protects your hot end. Okay, so let's see if I can zoom in. Whacking my phone. Come on, zoom. I'm going to bring this down so you can see it. Okay. Now we are in picture. So this little brass piece here, that's actually the nozzle. Okay, so this gets up to 215 degrees Celsius minimally to print PLA, higher for other materials. So if you might remember from science class, water boils at 100 degrees Celsius. So we are printing at more than twice the heat of boiling water, which is why we don't generally let patrons go sticking their hands in there, because you can get pretty severely burned if you were to touch this when it's heated and ready to go. Obviously, it's not heated right now. The next piece up, this is called the heat block, okay? And it basically serves to distribute the heat from, see these red cables here? Okay, you can kind of see it. That's the heat cartridge. So that is connected back to the brains of the machine, which is over here in this box. And I'll show you that. And basically that's what actually adds the heat to this whole element. So this little cartridge heats up, it's ceramic on the inside, and it heats this heat block, and that in turn heats the nozzle. And so this is what we call our hot end. This white cable here goes to what's called a thermistor, and that's a special type of resistor for heat. Thermo, heat, pretty easy. So that thermistor is constantly monitoring the heat of the heat block, because if this heat block overheats, everything can burn. And people have actually had their major fires catch. So that's there as a safety function. Sometimes that can get damaged. You can see that that's pretty easy. If you're not careful, that will get damaged and remove the insulation. So it's good habit to always check these things carefully before you start a big print. This is basically meant to reduce the heat. So this is going to basically be a block to baffle the heat away, so that it doesn't build up and then deform or melt your printed parts. But it keeps it warm enough so that this filament, as it's coming down into this, it's warming, finally hits the nozzle and melts. And you want to kind of keep that just right, because if you end up with too much fluid in here, you get a pretty bad print. So that's your basic hot end there. This, I'm going to take off this motor now so that you can see what's going on the inside. So that's pretty easy from behind. This is actually a very surprisingly heavy motor. It may not look like it, but it is. And you may notice, let's see, you may be wondering if you can see it. Can you see it from this video? Not really. Back here, there's a little, kind of looks like an eraser off of a pencil. We call that the pinda. It's a special type of sensor that actually can sense how close it is to the bed. And it helps to keep everything level, helps to keep it printing smoothly. So that was a huge upgrade in the technology when that was figured out. And then these days, I mean, some of the early 3D printers, everything was extremely manual. Now there's a lot more automation. It makes it much more easy for, hobbyists to get involved with 3D printing, which is pretty exciting. Okay. So removing that motor, you can see, I hope you can see. Yeah. Gonna zoom out just a little bit here. There are gears here. Okay. So you can see the filament now coming down into the hot end. And there's a bit of tubing there that accepts that filament. And there's a piece here that keeps that tubing locked in really tight, because what can happen is if there's a gap anywhere in here, it's going to fill with melted filament and it's going to gum up the works. So we don't want that. But these gears actually help feed the filament in. So they've got little teeth and there's another set on the inside that you can't see so well right now, but together they work to actually push the filament down. Okay, and that's part of the extrusion. And getting that just right, at just the right speed, just the right flow is really important in making a good 3D print. You don't want it set too tightly either, because that's really going to mess with your print's ability to flow. So it's a delicate balance that you need to constantly be aware of. I'm just kind of looking. I've been having a little trouble. I will be honest, I've been having a little trouble with filament today. Okay, so that's the basics of the inside of a 3D printer. I know it doesn't look like much. It's basically a fancy hot glue gun with a gear that feeds your hot glue, as it were. But there are a lot of tiny little things that can go wrong. And so that's part of the fun of 3D printing if you choose to get involved as a hobbyist, is that there's a lot of things that you can tweak and upgrade and get really involved in the mechanics. Okay, I hope that you found that fun and enjoyable and interesting, and I hope that encouraged you to give 3D printing a try. It's a great technology. It's something that's not going away. It is a technology that's going to be here for a long time. It's constantly growing and updating, so it's a great future career path, and it's great for hobbyists too that just want to do something creative. All of the information about our 3D printers is included on our website at warrenlib.org. Go to the Makerspace page, and we have the details on how to send in a file to have it 3D printed. Basically, you need to download your file as an STL, email it to us. We'll go back and forth, and I'll give you an estimate about how much it's going to cost. We charge 5 cents per gram, which means most items that people send are very inexpensive to produce. You're going to choose your color, choose your filament, and then when the print is done, you'll get an email saying to come and pick it up, and you'll have 1 week to do that. Right now, they are not available for curbside pickup. We haven't added that yet to the system. I'm hoping in July and August that we'll be able to do that. So that means that you have lots of time to be able to learn about 3D printing and start fabricating your own designs. As I mentioned before, there is a longer video, okay, on our YouTube and Facebook pages that goes into using Tinkercad, a free CAD software, computer-aided design software that you can use online so that you can get started, okay? And if you have any questions about that, my email address is sroberts@warrenlib.org, and I am happy to answer your questions and help you through the process of creating with 3D printing. All right, thank you so much for joining me. I will see you next week at 5 p.m. for another tool time. Next week, we'll be exploring screwdrivers and all their wonders. And definitely check out our Facebook, or website, for our events calendar, because we've got a ton of great stuff planned for you this summer. We've got our summer reading program. It might all be online, but hopefully we'll be back into the library soon. Hopefully we can do programs again soon. But in the meantime, we're still here for you. Okay? Stay safe, stay healthy, and take care. Bye.